After the kinematics and dynamics of rigid bodies, we need to understand various types of energy of a rigid body. The potential energy of a rigid body possessed by Earth gravitational field is called potential energy. Then we have the energy possessed by a rigid body due to its motion is called kinetic energy of the rigid body. And kinetic energy can be subdivided into two parts. One kinetic energy is due to rotation, that is called rotational kinetic energy. Another kinetic energy is contributed due to the translation of rigid body, and that is what we call translational kinetic energy. So, in this section we need to consider the kinetic energy of a rigid body. If we take a rigid body which spins with angular velocity omega and its center of mass moves with the velocity Vc, the kinetic energy of the rigid body, if you want to calculate, you have to take an element, very small segment of the rigid body of mass dm. If you stand at the center of mass, you can see that the small segment moves in this way with the velocity r omega, and that is the velocity of the element with respect to the center of mass, as we have discussed in the kinematics of rigid body. If you add the center of mass velocity, the velocity of the elementary segment, the velocity of the element you can calculate. But let us take the element. The element at the point P moves with the velocity r omega with respect to the center of mass. If you add this velocity of the point P or the element P with respect to the center of mass, with the center of mass velocity, we are getting the velocity of this particle or velocity of this element with respect to ground. So, the kinetic energy of the element with respect to ground is dk is equal to half its mass into its velocity square. The velocity of this point, according to Galilean transformation of velocity, is equal to Vpc plus Vc. This is equal to Vpc square plus Vc square plus 2 Vpc dot Vc. Square root of this. Then you can write the kinetic energy of the element is equal to half dm Vpc square plus half dm Vc square plus half dm Vpc dot Vc. The total kinetic energy of the rigid body is obtained by integrating the kinetic energy of all the small segments. Integration of dk. So, half dm Vpc square integral plus half dm vc square integral plus half two will be there, 2 getting cancelled, integral dm vpc dot vc. This is the kinetic energy of the entire body with respect to the center of mass frame, because half into mass of the element into the square of the velocity of that element with respect to center of mass frame, the integral of this. So, this physically signifies the kinetic energy of the rigid body with respect to center of mass frame. If you treat the second term, this is a constant quantity, vc square into half can be taken out of the integral. So, only this term dm is left behind. If you integrate from 0 to m, the mass of the rigid body, you are getting the term half m vc square. Therefore, this term, if you look at this term, you are having half into mass of the total rigid body into the square of the center of mass velocity. So, we can call it kinetic energy of the center of mass. And if you simplify this term, Vc is a constant quantity. So, you can just write Vc dot dm vpc. If you take the third term, a dot b can be written as v dot a. vpc dot vc can be written as vc dot vpc. You can put dot vc out of the integral, or if you do not like this, you can just write in this way also. You can write, you can take dot vc out of the integral, and this physically signifies, physical significance of this term is sum of moment of all points, all elements with respect to the center of mass, and that is equal to 0, as you know, in accordance with the property of center of mass. With respect to center of mass, sum of moment of all particles, all elements of the rigid body, or it may be a group of particle, discrete particle system, or it may be continuously arranged particle system like a rigid body. The sum of moment of all particles with respect to center of mass is always 0. In this way, we are left behind with these two terms. So, we have two terms of kinetic energy. One, kinetic energy of the rigid body with respect to center of mass frame, that is equal to half dm vpc square integral plus half m vc square. If you expedite this procedure to simplify this first term, you can write vpc is equal to r omega plus half m vc square. Omega is a constant quantity, so you can take omega square by 2 out of the integral. So we are having this term which is known as moment of inertia of the rigid body with respect to the center of mass prime. Omega square by 2 into IC, because R is the position of the elements with respect to the center of mass prime. So we can write IC omega square by 2 plus half mvc square. This is the IC, moment of inertia about the center of mass axis. This is the kinetic energy of the rigid body. We have two terms. The first term is kinetic energy with respect to center of mass. The second term is kinetic energy of the center of mass. Since omega is not equal to 0, the body is rotating, and the kinetic energy due to rotation is called rotational kinetic energy or kinetic energy of rotation. Here, when Vc, center of mass velocity, is not equal to 0, the rigid body is said to be translating. Then this kinetic energy is called kinetic energy of translation. Is equal to half mvc square, and kinetic energy of rotation is equal to half IC into omega square. And this is the total kinetic energy of the rigid body with respect to ground. Okay, so we got the formula. Kinetic energy of rigid body is equal to kinetic energy of translation plus kinetic energy of rotation. Translational kinetic energy is equal to half m vc square. Rotational kinetic energy is equal to half IC and omega square.